Today we are looking at the mode, median and quartiles of a continuous random variable using the cumulative distribution function, at least using that for the median and the quartiles. Don't want to spoil the surprise too early. Okay, let's look at a continuous random variable. So let's have, oh, that's a really bad straight line. So let's sketch one. And there's a little, oh, hello. So, let's do the mode first of all. Now, okay, here's our piecewise function as well, just to go with our beautiful looking graph. Otherwise, the mode, as you know, mode means most frequent. So the number that occurs the most. Most frequent, okay, let's think this is our frequency. So the most of the frequency, the most frequent is going to be our graph reaches the climax. So that, and this would always be the turning point if it is a curved graph. And how do you find the turning point? You just find the turning point. So, for the mode, the turning point is found by differentiating, of course. Remember, differentiating finds the gradient, and at the turning point, the gradient, if you zoom in, is 0. So you need to differentiate our function to find its gradient, and where that equals 0 is our turning point. So differentiating, so increase our, so that's like power of 1. So multiply by the power, and then reduce the power by 1. Times by the power is 12, reduced by power by 1 is 2. Which gives us 4 minus 12x squared is 0. Quick bit of rearranging and etc. would give you x squared is 4 over 12. Let's square root those sides. So x will be either positive 1 over root 3 or x is negative 1 over root 3. And given our graph goes only between 0 and 1, 0, 1, it can't be the negative 1. Therefore, our mode is 1 over root 3. Hey, that was nice. Now, let's think about our quartiles and our median. So, your quartiles, so the lower quartile is 1/4 of the way of the values up. Yeah, so if you accumulate all your values, it is 1/4 of the way up. And I said accumulate for a reason, because this is where we're going to need our cumulative distribution function. So the problem with finding the lower quartile is you can't really tell at what point 1/4 of the values have occurred up to this point. Equally, our median is going to be where you've had half the values. This could be here, could be there, whatever it takes to have half of our values occur before this point. And then, what colour is this? Blue? Nope. Yeah, black will do. And then your upper quartile is going to be where you've had 3/4 of the values. So some point up to which you've had 3/4 of the values. And there's no guarantee these can be evenly spaced along this line, because it's based on the area. So the lower quartile, you're going to need to find some value in your cumulative function which gives you an area of 0.25. For the median, you need to find some value, let's call it m, gives you an area of 0.5. And the upper quartile is going to be, again, some value. Let's use, why not u? Gives us 0.75. Now, some textbooks and things would use rather than L and U. It probably is more mathematical things such as Q1. The reason I'm not using it is a personal choice, just because if I use Q1, I'm writing Q1 squared or something, I'm just not a big fan of seeing like two numbers attached to an item. But mathematically, that is probably the more rigorous version. So, to make our lives easier, now you could integrate every single time to find out the areas, but let's just do it once. So let's find the cumulative distribution function. I might just reserve this graph at the top, just about see it. So our cumulative distribution function, let's go with some green, is where we integrate between x and negative infinity. We're going to use t because remember, we're going to substitute in x, so we use t instead. So our cumulative function is going to be 4, increase the power by 1, divide by the power. Increase the power by 1 is 4, divide by the power, between 0 and x, because our graph starts at 0. And we're going to substitute in x for the t's. So it's going to give us 2x squared minus x to the 4. Take away 0, so 0 squared, or 0 to the 4, that's going to be a value of 0 anyway. So therefore our cumulative distribution function is described by 2x squared minus x to the 4. So our cumulative function, f of x, so below 0, the graph goes flat, so there's nothing to accumulate, nothing to build up. So anything x less than 0 has a value of 0. Between 0 and 1, we've been described by this function here. Between 0 and 1, and then beyond that, because it's cumulative, you reach your maximum of 1. So any value of x is greater than 1, it's going to be 1 as our solution. Now I'm going to show you the median, and the theory for the quartiles and upper quartiles is exactly the same. So I'll show the median, then I expect you to try and work out the quartiles, and then come back and compare it to my worked solution. Okay, let's get rid of some of this malarkey going. Let's hide all this stuff. Let's keep it simple. Okay. So according to our graph, our median, do you know what? I'll be nice. I'll do the lower quartile. How about that? So the lower quartile is where you have 0.25, sorry, of the area less than this point. So the point at which you've accumulated 0.25 of all of the distribution. So we need to find, I'm using L here for lower, in a cumulative distribution, where the cumulative distribution function equals 0.25. Now, we know our function here. So I'm going to substitute x for an L, 2L squared minus L to the 4, and when that equals 0.25, that would have been where we've reached our lower quartile, when we've added up 0.25 of the graph. Right, let's take 0.25 from both sides, gives us 2L squared minus L to the 4 minus 0.25 is 0. Not a fan of decimals, so I'm going to times it all by 4. Gives us 8L squared minus 4L to the 4 minus 1 is 0. Now a little bit of trickery here. You've probably seen this little trick before, hopefully. If not, well, L squared is the same as L to the power of 1 squared, and L to the power of 4 is like L squared squared. So L squared to the power of 1 even, sorry. I think this through. So what I'm going to do, I'm going to substitute, rather than L squared, I'm going to use Y. Because then that gives us 8Y to the power of 1 minus 4y to the power of 2. Subtract 1 is 0. And now we have a nice, beautiful quadratic to solve. And we can solve quadratics. That's quite useful. Typically, you'll see this trick where you have powers, so one is double of the other one. So if it's 3 and 6, 5 and 10, you just change what you're substituting in for to end up with a quadratic. Now, I can't factorize this. No. So we're going to use the quadratic formula. You should remember that as a big fan from GCSE, that x is minus b plus or minus square root of b squared minus 4ac all over 2a. But I'm quite sure you had that all off by heart by now anyway. You've probably done it 1,001 times. And I'm sure you can quite capably substitute in numbers into that, where this is your a value, your b value, and your c value. And you've got two solutions. Now, you had y is 0.1339 something or other going along. Or you'd have had y is 1.666 something or other recurring. Now, bearing in mind, we're not after y, we're after our lower quartile L. So you're going to have to, in L squared is y, so saying L squared is 0.1339, etc. And L squared is 1.666, blah, 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 blah. So you're going to square root both sides. 366, and you square root this, you still get a solution that is bigger than 1. Okay, now, you've got two choices. It's going to be around 1.28-ish, roughly speaking. Two choices. Only one is correct. Now, given that our range of our cumulative function is between 0 and 1, therefore, our solution must be the one in that range. 0.366 is our lower quartile. Now, all you need to do is go away, literally go, not literally go away, just do some work. And the median is going to be stacked up half of our values, so exactly the same process, but rather than 0.25 at the start, this is 0.5. Then our upper quartile, I'll use a U for this. Again, Q3 is more mathematical, but that is when it comes to 0.75. So again, same process, but rather than 0.25 or 0.5, so when it equals 0.75, and you've had 3/4 of that graph. There's your graph, so 3/4 of it, and you've got the lower quartile of 0.366, and as you go along, draw the graph, and just check logically that it does follow on in order. If your median is lower than your lower quartile, that's kind of an issue. And vice versa with the upper quartile and all that jazz. So, go away, find those two, come back, and let's see if you got it correct. Because we are short on time, I've squeezed both solutions into the same view, so you can pause it if you need to have a closer look. Upper quartile, I factorized. Median, I used the quadratic formula. The median had a value of 0.541. It was the only one in the range. And in the upper quartile has a value of 0.707. Again, it was the only one in the range of 0 to 1.